The JSON format is a lightweight way to store and exchange information. It uses a syntax that is widely understood by computers and relatively easy to read for the human eye. Despite its roots in JavaScript, JSON is language independent, meaning that it allows for various programming languages to work with it. Hi, my name is Gene and welcome to Do Some Div. In this video we'll talk about what JSON is and what its advantages are. And then we'll take a quick look at where JSON is used most and what it actually looks like. After that, we'll quickly walk through a couple of examples showcasing how JSON travels between apps in the most important programming languages of today. The examples provided in this video are in JavaScript, Java and Python. This way you have a good starting point on how and when to implement JSON in your projects. Let's start with the question, what is JSON? JSON stands for JavaScript Object Notation, but it is used within all modern programming languages to represent data. It's known for being lightweight, smaller in size and easy to read. And it uses a structure similar to XML, namely due to key value pairs and nested data structures. Just take a look at this exact same data in XML and in JSON. Can you see how JSON offers a clear advantage in readability compared to XML? This makes it a breeze to learn and use. Because of its widespread adoption, nearly all programming languages have built-in or readily available libraries to parse and work with JSON data. This ease of use extends over all major platforms including Windows, Linux and Mac. So where is JSON used exactly? It certainly is a popular choice for exchanging data across the web. Many applications leverage APIs to communicate with each other using JSON. APIs provide a way for applications to access and exchange data in a structured format. JSON's readability and efficiency make it ideal for this purpose. In some cases, applications might store configuration data in JSON files for easy access and modification. Let's take a look at the types that JSON can represent. One possible type are numbers. Those could represent integer, for instance 1022, decimal, for instance 12.49, also negative numbers like minus 432.99, and numbers in scientific notation such as 8.76 times 10 to the 5. Then there are strings that can contain any letters and can vary in length. They have to be enclosed in double quotes. Single quotes are not valid for JSON strings. Examples include John Doe, Olivia, or simply A. Boolean values are represented by true or false. There is also a null type that represents the absence of a value. Arrays are another type in JSON, representing ordered collections of elements. These elements can be of various types and are denoted by squared brackets, for instance 1, 2, 3, or strings like apple, orange, banana. JSON also has the object type, which is the most complex type. Objects are denoted by curly braces that have any number of key value pairs that are separated by commas. Keys act as unique identifiers within objects and must always be strings enclosed in double quotes. Values can be of any JSON data type that we've discussed here. Okay, let's take a quick look at an example data in JSON. The first thing that we need here are the curly braces. And let's create a list of our favorite pets. Defining a key called pets, holding an array, meaning that we need the squared brackets. Then we start by creating a first object and defining our first entry with a key species and the value cat. Next, let's create the entry age and give it a null because we don't know the age of our cat. Next, we create another Boolean entry for whether our pet is trained or not, which is false with our cat. And let's end this with an array of favorite toys, which is the laser and a feather. Our cat loves lasers and also feathers. Let's create a second pet. So let's start with a comma and then the curly braces. The species is a dog, the dog's age is 5, and yes, it is trained, and the favorite toys are a ball and a frisbee. Let's create an example of a JSON object in JavaScript. The first thing that we need is a basic structure in HTML, consisting of the doc type HTML, then the HTML element, and then a head element. Within the head element we define the title, and within the body element we start with a header h2 animal info. Also within the body we define a script of type text JavaScript. And now we can already define an object that we store in a variable animals. This object consists of an array of animals, starting with the animal dog. His name is Max, the breed is a golden retriever, and his age is 2. Then we have another animal, cat. Its name is Luna, the breed is Siamese, and its age is 1. We already have the possibility to output the animals to the browser. So let's quickly check what this looks like. By opening Google Chrome, we can press F12 to open the Chrome DevTools. This gives us the possibility of an insight what has been printed to the console. What we see here is the object that we just created. But that's just about it. So let's create a couple of fields that enable us to see a couple of values within the interface. To keep it simple, we create a table where we insert a couple of labels and a couple of read-only input fields. One for animal, one for name, one for breed, and one for age. So currently we just have a couple of fields, and we also want to fill them with data. For that, we first need to get one single animal. So let's take the animal that is located at index 1 within the array, which is the cat, because the dog has the index 0. Next, let's take the single animal. For the single animal, we create ourselves a variable with the same name, single animal. What we do now is extract value by value and fill in the fields. For the animal, for the name, for the breed, and for the age. Okay, let's take a look at what this looks like in the browser. Refresh the document, and there we go. We have all the information about the cat. Of course, if we want to have the information of the dog, we need to change the index to 0, save the document, and refresh the browser. And there we go. Now we have all the information about the dog. Okay, there's just one thing though. Normally, an API communicates by sending us the JSON document as essentially a big string. Hence, for accessing those values, we first need to convert it into an object. This can easily be done by a command called json.parse that takes the JSON in string format and converts it into an object that we can use. Alright, so let's save the file and refresh the browser. And there we go. We can see the dog, or if we change the index back to 1, we can see the cat. As we have already discussed, JSON takes place within APIs. So let's build one in Java with Spring Boot. So let's quickly create ourselves a project with Spring Initializer. The project will be a Java project, having the build automation Maven. Then the version that we use is 3.3.1. Conveniently, we call our group com.dosomedev. The artifact and the name are animal-demo, and the description is demo animal API. The packaging that we choose is jar, and the Java version is 22. What we also need is a dependency of Spring Web. Alright, let's generate. Okay, the zip file is downloaded, so let's unzip it. And let's add a new class that we put into a new folder model. And the class will be animal, having the same structure as in our previous JavaScript example. So the fields that we need are animal, name, breed, and age. And as they are all private, we need getters and setters. And we also need an empty constructor for this class, as well as another constructor having all the fields, namely animal, name, breed, and age. That's it for the animal class. What we need now is an animal controller class that we place in the new folder controller. Let's start by defining this class as a REST controller, providing a general request mapping /API. And as we want to access the API from multiple locations, we add the cross-origin annotation. What we need now is a method for getting the animals. So let's build a method animals that returns an array list of animals. Within this method, we define a variable animals of an array list of animals where we add the dog Max, the cat Luna, the duck Daisy, and the rabbit Poppy. This is the array that this method returns. Let's connect this method to a get mapping of /animals. The only thing that's left is running it. For that, we create ourselves run scripts, one for Windows, starting with @echo_off, and then mvnw spring boot run. Then we create another script for Mac and Linux, addressing it to bin bash, and the command is pretty much the same, mvnw spring boot run. The only thing that's left for the Mac and Linux run file is to provide execution rights, and then executing it. And there we go, it started in under 1 second. Let's check the result in the browser. This API runs locally, therefore we need localhost :8080/API/animals. And there we go. This is what the JSON of our API looks like. Now that we have an actual API, let's update the JavaScript file. Before we created our own object, but let's make a call to the API instead. For that, let's duplicate the file that we already have and create ourselves a JSON-example-2 HTML. We barely need anything here, so let's remove everything and keep the allocation. Let's create a new function that we call displayAnimalInfo. The first thing that we do is use fetch to access the list of animals within the API. Then the next step is to pass the JSON to an object. And that's it. We already have a variable called animals in which we have the entire list of animals. So let's just load the animal entries at index 1 into the 4 fields that we've already defined. And in the case that we encounter any error, let's just empty the fields. We also define ourselves a new button that triggers the function when we click on it. Okay, let's check this file in the browser. First the fields are empty, and now we click on a button and there we see the magic happens. This example seems a bit static, so let's create another label and an input field to be able to enter an index. For that we add the index as a parameter that we call animal index. First we need to make sure that this value is numeric, because as this is a text field it could also be a string. And then we need to make sure that this index actually exists, and if it does not exist we enter a 0. Of course now we don't access the animals by a fixed index and instead by the new variable animal index. Let's reload our example in the browser. There we go, we have our new field. By clicking the button Show Animal Info, we put the index 0 in the field and load it. What we see here is the dog Max. If we change it to 1, we see our cat Luna. If we set the index to 2, we get the duck Daisy. And if we set it to 3, we get the rabbit Poppy. The JavaScript example works well. So let's prove our point and create a GUI example in Java, accessing the JSON through the same API. So let's start right off and create ourselves a batch script for Windows, calling Maven to generate the archetype for us, Maven archetype quick start. Let's also create a bash script for Mac and Linux that essentially does the same. Let's provide execution rights for the bash script and run it. And here we go, we have the basis for a new project. Let's open up the POM XML file and add a few settings. The first one is that we set the Maven compiler source to Java 17, as well as the Maven compiler target, also to Java 17. What we will also need is a dependency from com google code JSON that we will need for parsing the JSON. In the resulting Java application file, we want to have all the necessary libraries, and for that we create ourselves a fat jar using the plugin named Maven Shade plugin. The phase that we connect the execution to is the package phase, and the goal is shade. For the manifest, we define our main application class, which is located at com/do-some-dev app. That's it. We are ready to start building the model of the animal. So let's create an animal class that essentially looks equal to what we receive from the API, meaning that our animal has the fields animal, name, breed, and age. And because all those fields are private, we create ourselves the appropriate getter and setter methods. What we also need is an empty constructor, as well as the second constructor taking every available field. Okay, that's it already for the model. Let's create ourselves the data part of our application. For that we create ourselves a data folder, and in that the API access class. We only want one API access in our entire application. So let's create this as a singleton and finalize it so it cannot be inherited. For that we need the private static API access instance variable, as well as a private constructor, followed by a static getInstance method that creates or just returns the instance. Okay, let's define the API URI to our API. We will also create ourselves a getAnimals class that does the actual call to the API. Right at the beginning we define our animal array and return it right away. And in between those two is what we get from the API. The first thing that we need is create ourselves a try-catch block for creating the URL to our animals API. In the case that the address has some errors, we catch them in the URI syntax exception and put out the error message. Okay, so let's create the actual connection to the server. We also define the request method to get, and after having done the call, we check whether the response code was 200, which means okay. If it's not 200, we throw an input-output exception error. That tells us that the data could not be retrieved from the web service. Okay, so let's create the logic for getting the actual JSON from the API and saving it into a string called response_body. For that, we create ourselves a new method that we call load_response_body, and that takes a connection. What this method essentially does is create a string builder and walking through every line that has been received, collecting it and converting it into a string. The next step after having received the response body is to convert it into an appropriate Java object. For that we make use of the JSON class, for which we also need to define a type token of the animal array so that JSON knows in what type of object it should convert. And there we go. After this step we have a list of animals. Now we are ready to build the front end. So let's create a folder called view, in which we create a new class called main window that extends jpanel because we use Java Swing, and we also implement action listener because we want to be able to catch button events. The first thing that we define are all the variables for the fields that we already defined in a JavaScript example, meaning a text field for the index, a button to make the call, a text field for the animal, a text field for the name, a text field for the breed, and another text field for the age. We also define ourselves an empty constructor, in which we will make the call for the field initialization. For a better overview though, we will put this into an own method that we call initFields. Here we define the text of all the labels, the sizes of the text fields, the text of the button, and that the text fields are not editable. Okay, let's call initFields from within the constructor. What we also need is to set up the layout, which is the grid bag layout in our example. This provides us with the possibility to position all the controls along X and Y axis, setting the index, the animal, the name, the breed, and the age. Let's make the call for setup layout in the constructor. What we will need now is to override the action performed method so that we can catch any event that comes from the button. So when the button is clicked, we first get the index, then we make the call to the API to get all the animals, then we convert the JSON string to the animal objects, and then we set the fields. And for setting the fields, we create ourselves a new method, setFields, that takes an animal object as a parameter. Now, if the animal object is empty, we empty all the fields. But if the animal object is not empty, we extract all the details and fill the fields. Okay, let's make the call to the setFields method, getting the right animal out of the array of animals according to the index number. And if the index does not exist, we throw an exception, invalid index, please enter an existing index. Due to the fact that our index number field is actually a text field, we could also enter text, which would be an error that we need to care for. If this happens, we empty the fields and output the terminal message, invalid input, please enter a number. Same thing for the index out of bound exception. We empty the fields and output the message. That's it for the main window class. Let's put it all together in a new viewer class. We start by creating a new Java Swing JFrame, providing a title, animal info, and a default close operation. And we also add and pack our main window and provide a new method to make it visible. That's it. The only thing that remains now is creating the viewer class from within the main method. To build the application, we create ourselves two scripts, one for Windows and one for Mac and Linux. For running the application, we need two further files, one for Windows and one for Mac and Linux. And both Mac and Linux scripts need to have execution rights. Now let's build and run the application. And there we go. Looks very similar, doesn't it? Let's try a couple of indexes and then press the button to load the data. We see the cat, we see the duck, we see the rabbit, and we see the dog. Now that we have a working example in JavaScript and a working example in Java, let's make this complete and create a GUI example in Python. Let's start right away by creating the model. For this we create a folder called model, in which we create ourselves an animal class. The animal class gets all the fields that we need, meaning the animal that we define as animal type, the name, the breed, and the age. That's it for the animal model class. We are ready for the data. We now can create the data class. For that we create a folder called data, in which we create the class API access. Here we start by importing the request library, which we will use to access the API, as well as the animal model class that we just created. Now we create the class API access. As we only want to have one instance of this class, we set it up as a singleton. For this we create ourselves a local variable called _instance, and we define ourselves a new method, in which we check if the instance exists, and if not, we create one using super new. Once checked and created, we return the instance to the caller. Okay, now let's create an init method, in which we define the API URI. Next, let's create a getAnimal method, in which we start by defining an array of animals, and then we prepare our URL to access the animals API. After that, within a try segment, we make the actual call to the API, followed by checking whether the status code returns something else than 200, and if so, we print an error, failed to retrieve data from web service. Now we get the JSON, followed by converting the JSON into an array of animals. To catch the potential request exception, we print to the terminal the web service could not be reached. After that, we return the animals array to the caller of the getAnimals method. Now we are ready to build the GUI. For that, we create a new folder view, in which we create a new class, main window. For everything that's graphical, we import the tkinter library. We also import the API access class that we just built, as well as the animal model that we created before. Now we are ready to create the main window class. The first thing that we do here is create an init method for creating a new TK instance and also for setting the title, animal info. Next we create a new method initFields, in which we define all the fields that we need, namely the label and the text for index, the button show, the label and text for animal, for name, for breed, and for the age. We also set the fields to read-only, and due to the fact that we need to change the read-only status for filling the fields, we create ourselves a new method called setFieldsReadOnly. Here we set all the relevant fields to read-only. We also need a second method called setFieldsNormal, in which we set all the relevant fields to normal. Also, both the init fields method and the setup layout method need to be called from within the init method. Now we create the setup layout method, in which we set the layout of the fields, and similar to the Java example, we place all the fields within a grid, meaning for label index and text index, as well as the button, and then for the animal, for the name, for the breed, and for the age. What we also need is a setVisible method, in which we make the tk call to main loop. Now we create a setFields method, which takes an animal object as a parameter. Before starting anything, we need to set the fields to normal. Then we delete the content of every field. And in the case that the animal object is not none, we insert the values to animal, name, breed, and age. After that, we make another call to set fields read only. Now we put our attention to the button show clicked method, which is triggered when we press the button. The first thing that we do is get the index, then we check whether it is a digit or not, and if it is a digit, we convert it to an integer. After that, we make the call to the API, get ourselves the array of animals, and then we check whether the index is valid within the array. If yes, we set the fields. If not, we empty the fields and print the message, invalid index, please enter the existing index. In the case that the index field has a value that is not a digit, we also empty the fields and print the message, invalid input, please enter a number. That's it for the main window. Let's create ourselves a viewer. The first thing that we do here is import the main window class, and then we create the viewer class. Here we create ourselves an init method, in which we create an instance of the main window class. We also create ourselves a new method called setVisible to further the call to the main window class and call the setVisible method. That's all we need for the viewer. Now let's put everything together in the main class. For that, we create ourselves a main.py, starting by importing the viewer that we just created, and then we create a main class, followed by creating an init method in which we create the viewer and set it visible. The last thing that we need is a little code segment to run the main method. To run the application, we create ourselves two scripts, one for Windows and one for Mac and Linux. The run file for Mac and Linux needs execution rights. Now we can run the application. And there we go, our tkinter Python GUI. Let's try out a couple of indexes. Index 1 for the cat Luna, index 2 for the duck Daisy, index 3 for the rabbit Poppy, and index 0 for the dog Max. Having explored the JSON format, I'm curious if you have already used it. Are you using it in one of your projects? Or do you prefer to handle things differently? Share your thoughts in the comment section below. Also, I've uploaded all the codes mentioned here into a repository on GitHub. This way you can check out all the examples at your own pace. You can find the links for that in the description of this video. Okay, I would like to thank you for watching this video. To sum up, you now know about the advantages of JSON. You have seen the structure and you know about the types that JSON can represent. And the three examples in JavaScript, Java and Python have provided you with an insight of what can be done with JSON in action. Alright, we're through with the JSON format. Drop a like if you feel this video has brought some value to you. See you in the next video.